Hello. Today we're looking at PMBus, and we'll use it to digitally control fault limits and monitor them on an LDO. Power Management Bus, or more commonly known as PMBus, is a digital serial interface for telemetry and fault reporting. We're going to use LTpowerPlay, a software-based tool from ADI Power Studio, to communicate over PMBus with the LT3074 LDO. LT3074 is an ultra-low noise, high PSRR linear regulator. It's also the first LDO with PMBus serial interface. The eval board for the LT3074 LDO is configured to output 1.2 volts and can deliver up to 3 amps load current. The part has a dropout voltage of 45 millivolts and can support an input voltage up to 5.5 volts. Let's set up the demo board to observe its behavior. First, connect the input and bias supplies. The input voltage must be at least 200 millivolts greater than the output voltage. The bias voltage must be at least 1.2 volts higher than the output voltage. During this demo, we'll set both input and bias voltage up to 3.3 volts. Channel 1 here is supplying the input voltage, and Channel 2 is controlling the bias. The green LED indicators for power on and power good are now lit. When you power on the board, the red alert LED will also be lit. We'll cover why later. Measuring from VO plus and VO minus, we could see that the board is correctly regulating the output voltage. We could show that the part also regulates well at high loads. If we set the current load to 1.8 amps, sure enough, the part continues to regulate. Now, let's leverage LT3074's PMBus capabilities and introduce LTpowerPlay, a PC GUI which provides complete access to the registers of the LT3074 LDO. Both Linux and no OS drivers are released. You could download LTpowerPlay for free at analog.com. To connect the LTpowerPlay to the eval board, use the DC1613A, which is a USB-A to PMBus dongle. The dongle is ordered separately. Before we connect the PMBus dongle, don't forget to turn off the eval board power supplies and load. Now you could attach the ribbon cable onto pin J12 of the board and plug the USB cable into your PC. I'm using a USB adapter here. As we return power to the board, we see the same behavior as before, with the LEDs lit and the LT3074 LDO successfully regulating. Now let's open LTpowerPlay. When you launch the GUI, you'll be in advanced mode. In this display, all supported devices currently connected will be represented here on the left. The configuration displays the register content across different tabs for easy navigation. The telemetry consists of status registers for input-output voltages and currents, as well as device temperature. And here, the telemetry plot offers a live display of the telemetry information. From the telemetry pane, we could view the status summary and status details, where we observe that status MFR specific register is flagged in red. When we expand on it, we could see the exact fault being triggered. In this case, the IOUT min fault. In the configuration pane, we could see that the minimum output current warning limit is set by default to 100.1 milliamps. Since we powered on the LT3074 LDO with no load, the part asserts this warning limit and turns on the alert LED once it completes the startup procedure. Let's add a 150 milliamp load to the circuit. The fault will not immediately clear. One way to resolve the fault is to complete a power cycle. With the load still attached, we could turn off power to the board. In LTpowerPlay, this causes a notification to be sent up, as it recognizes that the device has ceased communication over PMBus. When we return power to the board, LTpowerPlay displays a new notification, acknowledging that communication has been re-established. This time, the alert LED is off on the hardware, since no warning limit has been violated since startup. Likewise, in the LTpowerPlay GUI, all statuses are depicted in green, confirming that there aren't any faults present in the system. We could also change register values from LTpowerPlay. Let's change the min-out warning limit from 100.1 milliamps to 200 milliamps. We send these changes to the board using the right PC to RAM button. A pop-up confirms that the update was successful. Since the 150 milliamp load does not satisfy the new 200 milliamp undercurrent limit, the fault has returned, both in GUI and on hardware. Let's change the load to 300 milliamps. As before, the alert stays on until it is manually reset. To preserve the register setting changes, this time we'll use the clear faults command instead of performing a power cycle. Clear faults can be initiated by clicking the clear fault icon on the LTpowerPlay toolbar. After doing so, the hardware and software again both indicate no faults. It's important to know that the LT3074 LDO's ultra-low noise performance is not impacted by PMBus communication. To learn more about all the capabilities of LTpowerPlay, explore the help menu available in the tool. You'll find the LT3074 LDO ideal for RF power supplies, high-speed and high-precision data converters, low-noise instrumentation, FPGAs, DSPs, microprocessors, and medical applications. Check out the LT3074 product page for links to simulation models like LTpowerPlay, the datasheet, and the eval board and its user guide. Any questions? Reach out to technical support or the Ask a Question button on the LT3074 LDO product page. Thanks for watching.